So in these sessions, I'd like to explain the gyroscope. Gyroscope is a spinning wheels. So this object is making a spinning motion. And this spinning axis actually also making the circular motions. So this spinning axis is making a circular motions. We call that this precessions. In the gyroscope, we could observe the combination of the two rotational motions. One is the spinning motion of the gyroscope itself, and the spinning axis also rotating around another axis. So we call that this is the precessions. So I'd like to explain this precession. So this is simple figures to describe the gyroscope. Because of the spinning motions of the gyroscope, angular momentum of the gyroscope is directed spinning axis. So this L is a spinning angular momentum. Because of the mass of the gyroscope, gravity is acting because of the weight. So W is correspond to the weight. So if you express the weight is a mass times gravity. Is a gravitational force acting the downward. So gravity is acting on the gyroscope. Spinning axis is directed on this direction. If you look at from the top, and the angular momentums has this directions, angular momentums. Then gravity is acting on this gyroscope, is directed downward. So this is the direction of the gravity, W. Then to find the torque, you have to find the vector quantities. Torque can be calculated. R cross W. So R cross W is this is the direction of the torque. Then we'd like to find out the change of the angular momentums. So if you remember the equations related to the angular momentum and the torque, dl dt equal tau. So from these equations, small change of the angular momentums is equal to tau times dt. So tau times dt, this is tau times dt. So this is equal to the dl. Then new angular momentums is expressed. This is L plus dl. So angular momentums making a circular motions. So angular momentum is changing the directions and returning to the same point. So this is we call the precessions. The angle, by changing this angle, you can consider this d phi. This d phi can be expressed L. This d phi is expressed L times d phi. So dl is expressed L times d phi. So d phi can be expressed dl over L. So precession angular speed can be expressed d phi over dt is expressed dl over L over dt. Then dl over dt is equal to the tau. So it becomes tau over L. So if you calculate the torque acting on the gyroscope and the angular momentums around the spinning axis, you can calculate the precession angular speed of the omega. I explained gyroscope, precession of the gyroscope. So we can apply the same equation when you consider the precession of the Earth, our Earth spinning motion around the spinning axis. This spinning axis precesses due to the gravity from the sun. Okay, this is the end of this lecture series. Thank you.